All of these plants have something in common. They all used to have grit removal systems that failed to capture enough grit. These systems did not work because they were designed with the assumption that wastewater grit settles like sand of the same size. These conventional systems did not account for the true settling rates of grit in wastewater systems. An accurate understanding of grit settling rates leads to correct design decisions and can stop grit problems cold. Municipal grit can best be understood by how it settles when it enters a wastewater treatment plant. To help us understand municipal grit, I'd like to introduce you to an acquaintance of mine, Gritman. While Gritman seems harmless enough, he represents one of the most prevailing menaces to wastewater treatment plants. Gritman is a sneaky fellow. He settles throughout the collection system but remains unnoticed. To date, nobody has paid much attention to him. You look at textbooks, look at the manual of practice, look anywhere. The understanding of the true settling characteristics of grit is typically glossed over and remains unknown. First of all, grit that enters a wastewater treatment plant is not just sand. It is a composite of a settleable particle such as sand coated with froth, grease, and oil. Thus, it settles more slowly than sand. Our industry's design manuals deal with grit as if it were exclusively clean sand. This understanding is flawed. It fails to account for the true nature of grit and the settling rate of this material as it enters a wastewater treatment plant. As a consequence, these systems fail to perform. Grit continues to deposit in digesters, in aeration basins, in pipes, dramatically decreasing plant performance and useful equipment life. But let's get back to Gritman. Hey, it looks like the Grit Gang is having a froth party. Sorry to break up the party, Gritman, but we need a better understanding of how you operate. Let's follow Gritman through a typical residence time in the collection system prior to entering the plant to understand why this innocent-looking particle poses such a significant threat to wastewater treatment operations. Lucky for Gritman, but not so lucky for wastewater treatment plants. Gritman won't have to wait very long. Gritman's frothy ticket to go with the flow should come along shortly.
Textbooks say pretend the grit is sand, but how it settles they don't understand. The froth makes grit settle really slow and acts like a much smaller particle. That's why conventional grit systems fail. Despite good planning, through them grit will sail. Don't you know that I learned it on the grit line? Grit gets frothed by the soap suds. Oh, I learned it on the grit line. Now it's covered with bloated.
Now we have assumed that Gritman settles according to his sand size. Frothy greases and oils that enter wastewater systems with soapy suds froth him up, resuspending him so that he can go with the flow. Due to the balloon effect of this attached froth, Gritman settles much slower, like a sand particle of a much smaller size. Due to the frothy grit effect, we need to think of municipal grit differently than we would think of sand as it enters the collection system. According to traditional sedimentation formulas that assume that grit has same as sand settling velocities, Gritman should be here. Yet Gritman has actually made it all the way here. For this reason, accurate grit system design requires using the sand equivalent size, or SES, of grit to account for actual grit behavior. The results of measurements of grit SES show that median grit settling velocity is independent of size. 100, 200, 500 micron grit particles settle at the same velocities as much smaller particles due to the frothy grit effect. These findings provide an explanation so we can finally understand where Gritman really is and how to design a grit removal system that will capture him and not allow him to sneak through. By not accounting for the frothy grit effect, traditional methods of planning and measurement for grit don't work. Unfortunately, a common misconception is that grit systems do not work. For example, the WEF Manual of Practice number 8 recommends designing grit removal systems with twice the calculated capacity to compensate for inefficiencies. This is a subjective way to deal with grit that dramatically increases the cost and space required for grit removal systems. Let's look at how traditional grit removal systems work. This froth grit remains suspended until the froth layer is removed by a biological process. One such biological process is anaerobic digestion. The bacteria in this process immediately remove the froth layer, causing the grit to lose its buoyancy and then to settle like a rock. This can lead to significant deposition, requiring shutting down the process completely and manually cleaning out the deposited grit. Digestion is just one of the many types of biological processes that can be impacted by unexpected grit accumulation. These can cripple performance in a wastewater plant by gradually reducing performance until the system no longer works at all. A high-performance grit removal system designed for the SES can guarantee grit capture rates of more than 95% of a total cut point particle size entering a plant. Many widely used low-performance systems have capture rates as low as 2 to 10%. The main reason these systems fail can be demonstrated as follows. A 100-micron SES wastewater grit particle settles in water at roughly 1.5 feet per minute. Most traditional systems are only designed to capture particles with settling velocities greater than 4 feet per minute. Consequently, grit sails through these traditional systems because they have not accounted for the actual settling velocity. Eutek's head cell system reduces settling distances and maximizes surface area to provide the system design required by the actual settling behavior of the grit. Now let's see what happens to the grit gang when they try to get past Eutek's head cell system. Another important consideration in grit removal is that most grit enters the plant during peak flow events. In plants with large peak-to-average flow ratios, up to 90% of the annual grit quantity enters the plant during 2 or 3 peak flow events. For this reason, effective grit capture requires peak performance at peak flows. Eutek offers custom-engineered grit systems with guaranteed grit capture performance at peak flows. Key points to remember. Grit is not just sand. Froth, soaps, and oil attach to grit, which slows settling velocity. SES accounts for actual grit behavior. Performance during peak flows is required.